Hello everyone. Today we'll dive into the topic understanding functions. Before we get started, don't forget to hit the like and subscribe buttons so you'll stay updated with my latest videos. Now don't let the word functions scare you. It's not as complicated as it sounds. In fact, functions are like little machines. You put something in and you always get a specific output. In this session, we'll explore what functions really are, the different types you'll encounter, and how to solve them. By the end, you'll see that functions aren't just about math. They're a powerful tool for understanding patterns all around us. Now, let's answer a very important question. What is a function? A function is simply a special relationship between two variables. Usually, we write it as an ordered pair like x and y. The first value, x, is called the independent variable, and the second value, y, is the dependent variable. Here's the key idea. For every input x, there is exactly one output y. Think of it like a vending machine. You put in a specific code for a snack, and you always get that same snack. You can't put in one code and expect two different snacks to drop out. That's exactly how functions work. One input, one output. Now let's talk about two very important ideas in functions, the domain and the range. The domain is the set of all possible input values, or x values, that you can use in the function. Think of it like the list of all allowed entries you can type into a calculator. The range, on the other hand, is the set of all possible output values, or y values, that come out of the function. So if the domain is what goes in, the range is what comes out. Here's a simple way to remember it. Domain equals inputs, range equals outputs. Just like a vending machine. The buttons you can press are the domain, and the snacks that come out are the range. Functions can also be grouped based on their values. The first type is a single-valued function. This is the most common one you'll see in math. It means that for every input, x, there's exactly one output, y. For example, if you put in the number 2, you'll always get the same result back. No confusion, no surprises. The second type is a many-valued function. Here, a single input, x, can give you more than one possible output, y. These aren't as common in basic math, but they do show up in advanced topics, like when dealing with square roots or trigonometric functions. So remember, single-valued functions are the standard in most problems, while many-valued ones are special cases in higher-level math. Functions can also be grouped into two big categories: algebraic functions and transcendental functions. Algebraic functions are the ones you probably see most often. They're built using the basic operations you already know, like addition, subtraction, multiplication, division, powers, and roots. For example, f of x is equal to x squared, plus 3x minus 4 is an algebraic function. On the other hand, transcendental functions go beyond algebra. These include functions like exponential, logarithmic, and trigonometric functions, things like e raised to x, ln of x, or sine of x. They're super important in advanced math, physics, and even real-world applications like sound waves, population growth, and finance. So, in short, algebraic functions are the basics, while transcendental functions are the more advanced tools of mathematics. Now let's talk about algebraic functions. These are functions that we can build using the basic algebraic operations, like addition, subtraction, multiplication, division, roots, and powers. One of the most common types is the polynomial function, which involves powers of x with constant coefficients. A special case of this is the linear function, a first-degree polynomial that gives us a straight line. And if we take it a step higher, we get the quadratic function, a second-degree polynomial that forms the shape of a parabola. So in short, algebraic functions cover a whole family of functions, from simple straight lines to curves like parabolas. Now, aside from algebraic functions, we also have transcendental functions. These are different because they can't be expressed using just the basic algebraic operations. For example, we have exponential functions, where the variable is up in the exponent. These are the ones that model rapid growth or decay, like population growth or radioactive decay. Then we have logarithmic functions, which are basically the inverses of exponentials. They help us solve for exponents when the unknown is in the power. And of course, the familiar trigonometric functions, sine, cosine, tangent, and so on, which describe relationships in right triangles and periodic motion. So while algebraic functions stay within the basic operations, transcendental functions open the door to much richer and more complex behaviors. All right, let's practice solving functions. Here we're given a function. F of x is equal to x raised to 3 minus 2x squared plus 5x minus 2. The task is simple. Plug in the given values for x and simplify. For example, if we want f of 0, we just substitute x equals 0 into the function, and the answer will follow after simplifying. We'll also try f of -4, f of 3, and even f of 2x, which is a little different because instead of plugging in a number, we're plugging in an expression. So the key idea here is substitution. Wherever you see x, replace it with the given value or expression, and then follow the order of operations. This way, we can evaluate or transform the function step by step. Now let's go through the solutions step by step. First, when we plug in x equals 0, the function simplifies quickly to f of 0 is equal to -2. Easy start. Next, substituting x is equal to -4. We have to be careful with signs. After simplifying, we get fe of -4 is equal to -118. For x equals 3, we plug it in and simplify to get f of 3 is 22. Finally, for f of 2c, instead of plugging in a number, we're replacing x with 2x everywhere in the function. After expanding, we end up with f of 2x is equal to x cubed minus 8x squared plus 10x minus 2. So notice the pattern whenever we substitute. The process is straightforward. Replace x, simplify step by step, and apply the order of operations. Let's wrap things up with a few key takeaways. First, a function always means one input, one output. Each x value corresponds to exactly one y value. That's the heart of what makes something a function. Second, we learned that there are two main types of functions: algebraic functions and transcendental functions. Together, they cover pretty much all the mathematical relationships we deal with. And finally, the process of solving is straightforward. Substitute and simplify. Replace x with the given value or expression, and carefully work through the steps. So, functions aren't just abstract concepts. They're a powerful tool that helps us describe, predict, and make sense of real-world situations. Remember, every function tells a story of how quantities are connected. Keep practicing, and soon solving functions will feel natural and intuitive. Thank you for learning with me today. See you in our next session.